Hello and welcome to this fifth feature engineering lecture in this course, Master in Artificial Intelligence. So, in this lecture, we will talk about the remaining steps of feature engineering and what these remaining steps are. Let's take a look at them. So, we have gone through first five steps from understanding the problems to dimensionality reduction, and we will now look at in this lecture the remaining four steps, starting with evaluating feature importance. So evaluating feature importance, how do you think you can evaluate feature importance? We covered this earlier, so this should be a quick recap for you. So what you need to do here is assess the importance of features in predicting the target variables, so the output variables, the y. In the classical, y is a function of x1, x2, xn. And there you need to know what are the model specific techniques or what are the feature importance scores. So you need to make this assessment, right? Assess the feature importance scores and use the model specific techniques to get the importance of features in predicting the output variable. And what you can do there is to analyze different how different features contribute to models prediction and identify the most influential feature. So a very practical point rather than only a theory of determining the scores while they may not ultimately affect the model's prediction, right? So do that. So understand the scores, find the scores, and also you analyze how different features contributes to predictions, right? Then what you need to do is to iterate an experiment. Now, what you need to do in iterating an experiment is to iterate through the steps 3 to 6 as you see here. After evaluating feature importance that we just saw, you need to go back to generating more features. So you need to use iterate through different engineering techniques, selection methods, and dimensionality reduction approaches. So at each step, as you go back and then come up again from steps 3 to 6, from feature engineering to evaluating feature importance, that's where the iteration would happen. And here you need to then continuously evaluate the impact of this feature engineering on the model performance and adjust your strategies accordingly. It's a hugely iterative process. Then what you need to do is to integrate domain knowledge into all that you found and experiment and iterated. How do you integrate domain knowledge? You need to incorporate domain knowledge with the help of subject matter experts and gain business insights into feature engineering process for a more meaningful and relevant feature. So use all that you know from the people who know this and the insights about business that you have gained, put that into the feature engineering process and create more meaningful and relevant feature. Now to do that, what you need to do is to collaborate with domain experts or stakeholders primarily to identify and engineer features. Find those features or find or develop those features that capture the most important aspects of the problem domain. An example, you know that a particular variable x is a thing that determines from the domain knowledge determines the output y, but you don't know in what form, what level of what format does it work. So you try with x, you try with polynomial, and it doesn't seem to work. It doesn't seem to explain the variances, and ultimately you need to then see is someone says, hey, why don't you try the logarithmic function? Then you try that and fits beautifully. So that's how you integrate domain knowledge and find the right algorithm. Finally, you need to validate and test. The question is, how do you validate and test? Any thoughts? So you validate and test the effectiveness of the engineered model using cross-validation techniques or holdout sets. And basically what you do there is you ensure that they generalize well to the new and unseen data. You have used the trained data, you have validated it. So obviously it's going to fit in there because that's what your model is based on. But check it out on the new unseen data and see how much does it come out true. And another thing that you can do is to finally test the final feature set on a separate test set, or to evaluate the performance on a real world scenario. And that's how you can validate and test. So by following these steps that we saw, you can effectively identify and extract meaningful features from data to improve the performance of the machine learning model, ultimately enhancing the predictive accuracy and robustness of the various applications. So what is next? So having looked at this whole process of feature engineering, we will now take you through an example of how to identify and extract meaningful feature from the data, how to do this feature engineering, how a company did that. Is that what we will talk about in the next lecture? So thank you so much for watching this fifth feature engineering lecture. I hope you are continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download a PDF file to take a look at anything that you need to.